students, welcome back to this new session. In this session, I am starting with the Poisson distribution. Previously, we have learnt about binomial distribution and also we have derived the mean and the standard deviation of the binomial distribution. Now let's see what is Poisson distribution. The Poisson distribution is regarded as the limiting form of the binomial distribution. Okay, in binomial distribution only, if we consider n tending to infinity, okay, and the probability of success, that is small p, very small, okay, we consider in binomial distribution only if we consider n tending to infinity and probability of success being very small, okay, and treat n into p, one is very large number and p is very small, multiplied together we call it as some constant, say m, okay. So the new distribution which we get after considering these two, it is called a Poisson distribution. Now let's derive the probability function of the Poisson distribution using the probability function of the binomial distribution. So we know, that is, we have to consider n tending to infinity and consider p very small in binomial distribution so as to derive the probability function of the Poisson distribution. By binomial distribution, the probability function of the binomial distribution, we have seen that it is ncx p raised to x q raised to n minus x, where p is the probability of success and q is the probability of failure. We have got this, okay. So I will just start my point from here, okay. So you have got p of x is equal to, let us expand ncx p raised to x and all that. So ncx can be expanded as n into n minus 1 into n minus 2, so on, into n minus x minus 1 divided by x over here, so it will be x factorial p raised to x q raised to n minus x as it is, okay. Now from each of these brackets, okay, how many brackets are there except this n? 1, 2, so on up till x minus 1. So it will be x minus 1 brackets. From each of these brackets I am taking n common, okay, one common from here, one n common from here, one n common from here, so on, okay. So after taking all that, so I will have, since there are x minus 1 number of brackets, there will be x minus 1 number of n's outside if I take out, okay, and if I multiply that with n, I will have n raised to x totally multiplied, okay. So the remaining part, it will be, since I have taken n common from here, it will be 1 minus 1 by n. Similarly, I have taken 1 n common from here, it will be 1 minus 2 by n. It continues, at the end it will be 1 minus x minus 1 divided by n into p raised to x, q raised to n, I will write it over in the numerator, whereas q raised to n minus x is there, so minus x comes to the denominator, x factorial q raised to x we can write, okay. Now this p raised to x and n raised to x, we can multiply together and write it as n into p whole raised to x. 1 minus 1 by n, 1 minus 2 by n, so on, 1 minus x minus 1 divided by n, q raised to n divided by x factorial q raised to x. Like this you will get, okay. Now see, since we are considering n tending to infinity and p very small and the two multiplied together and stated m, so we will write n into p as, say, m, okay. Secondly, when n is tending to infinity, let's see what is happening to q raised to n, okay. So q raised to n, you know that q is 1 minus p, so q raised to n will be 1 minus p to the power n, okay. But what are we considering? N into p is equal to m. So what is p from here? M by n. So it will be 1 minus m divided by n raised to n. Okay. Now I will readjust the terms over here and write q raised to n as 1 minus m by n raised to minus n by m, this raised to minus m. Can I write it like this? if I multiply with and divide by to this power, I am multiplying and dividing by minus m, so that n is there still. Okay, it gets cancelled, minus into minus plus, so this will thing. Okay, now in this we'll put if I consider, instead of putting, I'll consider minus m divided by n as some k. Okay, so if I do so, minus n by m will be 1 by k. Okay, and limit as n tending to infinity, what will happen to k? K will tend to 0. So therefore limit as n tending to infinity of q raised to n will be equal to limit as n tending to infinity of 1 minus m by n whole raised to minus n by m whole raised to minus m. Okay, or this is actually equal to limit, because we are substituting it as k. So as n is tending to infinity, k will tend to 0, so it will be limit as k tending to 0 1 plus k, because minus m by n is plus k. Okay, raised to, this is nothing but 1 by k. 1 by k is minus n by m. Okay, and this raised to minus m you are having. Now see, you have learned one important in calculus, you have learned one important limit. What is that? Limit as k tending to 0, 1 plus k raised to 1 by k is always equal to e. This is the standard limit. Okay, you will have derived it before in first year, PUC first year only, while studying the calculus you will have done it. So with this, limit as k tending to 0, 1 plus k raised to 1 by k is always e. So this reduces to e to the power minus m. E to the power minus m as it is. This reduces, this if you apply limit as k tending to 0 to this, it is reducing to e to the power minus m. Okay, so knowing all this, and along with that, so we have discussed what is happening to q raised to n when n is tending to infinity. Okay, next let's see about the brackets, what happens. Okay, when n is tending to infinity, it will be 1 minus 1 divided by infinity, 1 minus 2 divided by infinity. All of these brackets will have the number divided by the infinities. Okay, a finite number divided by the infinity. So anything divided by infinity is 0, so all the brackets will result in 1. So n raised to, yes, it will be m raised to x. So when n is tending to infinity, we are treating this n into p as m, so it will be m raised to x. So let us apply that together. So as n tends to infinity, let us apply that together to this p of x. The p of x, the probability function of Poisson distribution, p of x can be regarded as, it will be m raised to x, because as n is tending to infinity, we are treating it as m, first thing. Second, all of these brackets are turning to 1. Okay, so 1 into 1 into 1, so that multiply together it will be 1 only. Now q raised to n, as n tending to infinity is taking the value e to the power minus m, so e to the power minus 1 m as it is, divided by x factorial is there, write it as, and q raised to x you are having. Okay, so what is happening to that q raised to x, we'll see. Okay, and one more thing, what is q raised to x actually? Just see, I had to discuss that point also. Okay, 1 minute, I'll see what is happening to q raised to x over here in just small this. So you have q raised to x in the denominator. Okay, let's see what is happening to that as well here and consider it over here. Okay, so q raised to x can be written as 1 minus p whole raised to x. Okay, I told you in our Poisson distribution, what are we considering? We are considering that p is very small. If p is very small, means we know that p plus q is 1. Okay, if p is very small, q is 1 minus p. Okay, it is this way, 1 minus p. Okay, so since p is very small, it is minus, it will be something like, I can consider it as approximately near to 0, p tending to 0 I can say. Okay, very small means p is almost tending to 0, not equal to 0, but it is just tending to 0. So 1 minus p will be approximately equal to 1, or I can consider that this 1 minus p is approximately equal to 1, or 1 raised to x is equal to 1. Okay, so that we can apply it over here. So as n is tending to infinity, this q raised to x we can treat it as 1. So therefore our probability distribution function, or I should say the distribution function for Poisson's distribution is this: P of x is equal to m raised to x e to the power minus m divided by x factorial. I have explained what happens when n is tending to infinity and p is very small. Each quantity, what happens to each of them in the binomial distribution only we have considered. The distribution function of binomial distribution only we have considered, we have expanded, and then for each n tending to infinity and p very small, for each of these terms present there, what happens to them, let's see, and substitute them in our p of x so that we get the probability distribution function for Poisson's distribution. Okay, so this completes the expansion, or I should say this is called Poisson distribution. This is called Poisson's distribution. Okay, now let's see whether it is probability distribution function also or no. Okay, so for probability distribution function, it must satisfy the two conditions. What are they? For all x, your p of x should be always greater than or equal to 0, and secondly, the summation of all p of x should be equal to 1. These two conditions it should satisfy. Only then this p of x will become a probability distribution function of x. Okay, let's see whether it will satisfy or no. Okay, and then we'll continue. So this is the distribution function we have got for Poisson's distribution. Now let's see whether it is actually the probability function for our Poisson's distribution. For that, let us write in tabular form what is the distribution. Okay, for x is equal to 0, if you put x is equal to 0 in the definition for p of x we have derived, it will be m raised to 0, which is 1, e to the power minus m divided by 0 factorial. 0 factorial, it is 1. Okay, so it will be e to the power minus m plus next one, when x is equal to 1, it will be m e to the power minus m divided by 1 factorial, which is also 1. So need not do anything, or you can write 1 factorial if you want. Okay, so now when x is equal to 2, it will be m square e to the power minus m divided by 2 factorial. 3, it continues, m cube e to the power minus m divided by 3 factorial, and it continues. Okay, it continues. Now we have, do we have p of x greater than or equal to 0? Just verify it. Now e to the power minus m present in each of the term can never be negative. Okay, for any value of m. Okay, similarly, n is very large and p is the probability of success. Probability of success p can never be negative. Since n is very large, both however small, but it is not negative. Okay, p is positive, here n is also positive, n into p, that is m is also positive. So each of the terms present over here, they are all positive, and these factorials will always be positive. So therefore each p of x is greater than or equal to 0. The first condition is satisfied. Next one, let us consider the summation of p of x. The summation of p of x for all x, it will be what? X going from 0 to infinity. It will be what? Because it continues, because you are tending n to infinity, so x has to vary from 0 to infinity. So it will be e to the power minus m plus m into e to the power minus m plus m square into e to the power minus m divided by 2 factorial plus m cube into e to the power minus m divided by 3 factorial plus so on. Is it not? Now this is nothing but e to the power minus m I can take common. Okay, throughout. So what you are left with inside, it will be 1 plus m square by 2 factorial plus m cube by 3 factorial plus m to the power 4 by 4 factorial plus so on up till infinity. Yes or no? Now, what is this actually? Have you studied the expansion for e to the power x? E to the power x expanded as 1 plus x square by 2 factorial plus x cube by 3 factorial. Is it not? So using this expansion for e to the power x, this is nothing but in place of x you have got m. So therefore it will be e to the power minus m into e to the power m. So multiplied together it will get 1. So therefore the summation of p of x is also equal to 1, and probability function p of x is always greater than 0 for each of x present there. So therefore the two conditions for the probability function are being satisfied. Therefore you can consider that, or you can conclude that p of x, which is equal to m raised to x into e to the power minus m divided by x factorial, is a probability function for the Poisson's distribution. Okay, now let's continue deriving the mean and standard deviation of the Poisson distribution. Now let's continue deriving the derivation for the mean and the standard deviation of the Poisson distribution. So where you know very well, the mean mu is defined by the formula summation x going from 0 to infinity x into p of x. Okay, x into p of x. So that will be equal to summation x going from 0 to infinity. Let's substitute the value for p of x which we have got for Poisson. It is m raised to x into e to power minus m divided by x factorial. Okay, you see that one of the x will get cancelled from this, or you can expand it as summation x going from 0 to infinity x into m raised to x e to power minus m divided by x into x minus 1 factorial. This x will get cancelled. Okay, so this is what you get. Okay, now let's continue expanding. Now e to power m has nothing to do with this summation because summation is holding for x, not for m. So e to power minus m can be taken out. It is summation x going from 0 to infinity m raised to x divided by x minus 1 factorial. Now since the x has been cancelled from here, I cannot take x tending going from 0 to infinity. Why? Because if I put x is equal to 0, you have negative factorial over here. So let's correct it. X going from 1 to infinity will take. Okay. Now since it has to start with 1, so let us take one of the m taken out. Okay, let us take it out. So it will be m into e to power minus m. I'm just taking one m outside. Summation x going from 1 to infinity m raised to x minus 1 divided by x minus 1 factorial. Okay, now let us expand it for m x is equal to 1 to infinity. M into e to power minus m as it is. Let us expand it for m x going from 1 to infinity. If it is going from 1 to infinity, it will be m raised to 0 divided by 0 factorial, which is 0 divided m raised to 0, which is 1, divided by 0 factorial, which is also 1, so it will be 1 plus. For x is equal to 1, it will be, it is done. For x is equal to 2, you will have m divided by 1 factorial. Okay, when x is equal to 2, it will be 2 minus 1. Plus for m is equal to 3, it will be m square divided by 2 factorial. Just go on doing it. M cube by 3 factorial. It continues. So what is this actually? This you have learnt already. So it is m into e to power minus m. This expansion is e to power m itself. Both multiplied, you will have m, right? Hence the mean mu is given by that constant m for that Poisson distribution. Okay, what is m? M is n into p over here. Okay, make a note. Next, let us derive the variance. The variance V is given by the formula. I had given this in my previous session also. X going from 0 to infinity, x square into p of x minus mu square. Okay, so first I will not take care about this. I will just consider the first part of this expression. So consider like how we are derived for binomial distribution. I hope you remember that. Same will consider that. Okay, x going from 0 to infinity, x square into p of x. Let us consider what this takes. Okay, so it is summation x going from 0 to infinity, x square into m raised to x e to power minus m divided by x factorial. Okay, you will get it something like this. Okay, so now this x square I want to change it. Okay, I want to write it like how we have done in previous. You can write x square as x into x minus 1 plus x. Can I do it like this? So it is x square minus x plus x. Minus x plus x will get cancelled. You still have x square. So x square can be replaced by this bracket. So let's do that. It is summation x going from 0 to infinity, x into x minus 1 plus x divided by x factorial into m raised to x into e to power minus m. Okay, now we'll separate the summations depending on the plus sign. I mean, we have got two terms over here. Okay, so summation x going from 0 to infinity, x into x minus 1 into m raised to x into e to power minus m divided by x factorial plus summation x going from 0 to infinity, x into e to power m raised to x into e to power minus m divided by x factorial. You will have like this. Okay, now let's continue further by cancelling few of the terms from the denominator, and we'll continue that remaining part over here. Okay, so the variance V is equal to, okay, not variance, right now we are working for that summation x square p of x we are working for. That is, we have got it to be summation x going from 0 to infinity. Now we have to expand it accordingly and cancel it. Okay, m raised to x e to power minus m divided by x into x minus 1 into x minus 2 factorial you can take, plus summation x going from 0 to infinity. You see, you can expand and write it. The next step I'm doing directly. Okay, so this x and these two brackets from here will get cancelled. Now since both of them had got cancelled, x cannot go from 0 to infinity. It has to go from x going from 2 to infinity. Okay, because it is x minus 2 factorial. If I take x as 0, it will be minus 2 factorial, which is not proper. Okay, so m raised to x e to power minus m divided by x minus 2 factorial plus summation x going from 1 to infinity. Earlier it was 0 to infinity, already one x is got cancelled. So we have to consider it accordingly. Okay, taking e to power minus m outside, we'll expand that remaining part and we'll see what we get. Okay, so I will take summation x going from 2 to infinity. I'll expand it as m square into m raised to x minus 2 into e to power minus m divided by x minus 2 factorial we can write, plus summation x going from 1 to infinity m into m raised to x minus 1 e to power minus m divided by x minus 1 to the power. Now whatever you have in the denominator, that same split we should do with m power. Okay, whatever m we have the power, we have to split it accordingly. Just see the denominator, you will understand. Okay, how to make a split. Why only m square taken out? Because you have in the denominator x minus 2. So you should take m square outside so that m raised to x minus 2 is left. Similarly, you have got x minus 1 in the denominator, so split it accordingly in the numerator as well. Okay, now just see, you can take m square into e to power minus m common. I mean, it's constant. Remaining terms I'm keeping out inside the bracket, inside the summation sign. So it is m raised to x minus 2 divided by x minus 2 factorial over here, plus m into e to power minus m, summation x going from 1 to infinity. Okay, m raised to x minus 1 divided by x minus 1 factorial, like this. Okay, now m square into e to power minus m, expand it for m is equal to 0, 1, 2, 3, 4 and all that. If you do that, it will be 1 plus m divided by 1 factorial plus m square by 2 factorial. It continues. Similarly, here also it will be the same. If you expand it, okay, just see, for m is equal to 2, it is 0, so it will become 1. M raised to 0 divided by 0 factorial, it is 1. For m is equal to 3, it will be m divided by 1 factorial. For m is equal to 4, it will be m square by 2 factorial. Continuous. Okay, and here also it will be the same. Okay, now see, both of these brackets are nothing but e to power m. So I am replacing both of these brackets as e to power m. You get m square plus m over here. Okay, but variance v is equal to summation x square p of x minus mu square x going from 0 to infinity. This value we have found, that is, it is this m square plus m minus mu square. Mu square is what? M square itself. Yes or no? So m square gets cancelled. The variance v is equal to m you are getting for binomial, for Poisson distribution. Since variance v is m, therefore the standard deviation sigma is equal to root of the variance, which is root m. Okay, hence we have found the mean and the standard deviation of the Poisson distribution. In my next session, let's continue with the examples on this. Okay, till then, thank you.